Good morning, children. So today again we are here with chapter 2. So in the previous class I have taught you how binary numbers are converted to decimal numbers and even decimal to binary. Even I have told you how octal and hexadecimal also are used to convert. Okay, that number can also be converted to binary but via decimal. First you need to convert to decimal. So children, I have told you that there are basically four number systems, four different type of data's representation way. Among that, binary number is the number which machine understand, whereas decimal, hexadecimal, octal are all human understandable language numbers. Among that, decimal is the most important and mostly used type of number systems. So children, the conversion part we have already done. Even I have given homework also to convert the number type. Hope you all have did that. So today we'll be doing some more operations on this binary numbers. We need to focus on binary as binary is the number type which machine understand, which each and every electronic or mechanical device they understand. Take the example of fan. It gets on when we press switch. Okay, even bulb also. Each and every electronic component they get on means they react or they communicate with us when we press the switch to on button. That means on is one. Okay, and when we off it stops. That means it stop responding to us, to humans. That is 0. So 1 and 0, the binary bits are understandable by each and every machine in this world. Computer is also a machine, so computer also understand this binary languages, binary numbers. So children, today we'll be learning some more calculations based on this binary numbers or binary bits. So see here, so today we'll be learning computer arithmetic. So children, arithmetic is like a mathematics part. So you know the basic mathematic calculations which you have did in your lower classes and all. So that is what addition, subtraction, multiplication and divisions. You know the rules also how these things are done. But in case of binary, addition, binary subtraction, multiplication, division, little bit rules are changed because here we don't use decimal numbers. Instead we use binary number. That means only the number which consists 0 and 1. So let us learn the rules for addition. Binary additions. So children, binary additions, let us take the examples of binary adding the two numbers. So basically I'll write here say bit 1 and bit 2. So 2 bit I'm just taking first 0 0 0 1 1 0 1 1. Let us do sum. Okay, now see children, in case of binary addition 0 plus 0, the answer is 0. Okay, and no carry. There is no carry for this part. Same with 0 plus 1, answer is 1 with no carry. 1 plus 0, answer is 1 again with no carry. Now when we have 1 plus 1, usually we write 2, but in case of binary we can't write 2 because 2 is a decimal number. So 1 plus 1, the sum, the answer becomes 0 and carry is 1. Carry is 1. So when we write 1 plus 1, okay, the sum becomes 0. This whatever I wrote, this is the value of sum. So when 0 plus 0 is there, sum is 0 with no carry. 0 plus 1, sum is 1 with no carry. 1 plus 0, sum is 1 with no carry. 1 plus 1, sum is 0 with carry 1. So children, this was the part of binary additions. Now in the same way, if you go for binary subtraction. Now subtraction means minus, difference. So let us learn binary subtraction part also. So see for binary subtraction. This is binary subtraction. Let us take again bit 1, bit 2, 0, 0, 0, 1, 1, 0, 1, 1. Minus part will be there, and here we'll be having say sum, and here borrow. So children, in case of this one binary addition, we wrote sum and carry, but here I'm not writing carry. In place of carry, I'm just writing borrow. Okay children, so you can just see the difference. In case of addition, there was sum and carry, CARRY, carry. Okay, but here now we have sum and borrow, BORROW, borrow. That means we need to borrow the bits when required. So 0 minus 0, sum 0, borrow is no. 0 minus 1, when we do 0 minus 1, that time we need a borrow. Okay, so answer is 1, but we need a borrow from left. Borrow from left. Left bit we need to ask a bit. Okay, borrow we have to do. When 1 minus 0, 1, again no borrow. 1 minus 1, 0 with no borrow. So see children, when we do binary subtractions, 0 minus 0, sum is 0 with no borrow. 0 minus 1, sum is 1 with borrowing from left. From left we need to borrow a bit. 1 minus 0 is 1 with no borrow. 1 minus 1 becomes 0 with no borrow. So this is the concept of binary subtractions. Okay children, so is this clear? Now let us move for binary multiplications. So children, binary multiplications. Multiplication. So again, bit 1, bit 2 will take as sum, but now there is no carry. In case of multiplication, we don't ask any carry or borrow. So 0, 0, 1, 1, 0, 1, 1. Now we'll do the multiplication part. So 0 into 0 is 0. Okay, 0 into 0 becomes 0. Then 0 into 1, 0 any number multiplied by 0 is 0. 1 into 1 is 1. See, it's a basic simple mathematic multiplication what we have learned in maths. In the same way for multiplication we have to do. Only the difference we are getting is in case of addition and subtraction. Multiplication as well as division, the concept will be almost same as what we have learned in our normal mathematic calculations. So children, once again I am saying you the multiplication rules in case of binary. If we have two bits, say bit 1 and bit 2, 0 multiplied by 0 is 0. 0 multiplied by any numbers is obviously 0. So 0 into 1 is 0. 1 into 0 is also 0. And when a number 1 is multiplied by 1, the sum is 1. Okay, so this is the basic multiplication arithmetic calculations. So is this clear children? So now let us move towards division. How to divide the binary bits among themselves. So see here. Multiplications, we'll learn binary divisions. So see here. Bit 1, bit 2, sum. Or we can write in this way. This is the division operator in case of computer, slash. Okay. So rule is same as what we do in mathematics. Any number we cannot divide by 0. So when any number is divisible by 0, when we are trying to divide by 0, the answer comes meaningless, not defined. So here also the rule is same. So when 0 is trying to divide with 0, so answer comes meaningless or not defined. Not defined. So it's not possible. It's not possible to divide any number by 0. So not defined. Okay. So 0 divided by 1. When we try to divide 0 by 1. Okay. So the answer is 0 only. 1 again. Denominator is 0. So not defined or meaningless. 1 divided by 1 is 1. So this is the simple division rule, which is same as what we do in mathematics. So children, from here what you understood, that in case of binary arithmetic or computer arithmetic, few parts are common, like addition, which sorry, not additions, addition and subtraction you have to follow the rules, but multiplication and division, these are similar to the way what we have learned in normal mathematics. So this chapter teaches us how the machine understand our languages or the numbers which we understand, and in the same way how machine translate, okay, into meaningful information and provide to us. That means our decimal is converted to binary, machine understand, again after that binary is processed to decimal and returned to us as a meaningful informations. So children, this very important chapter, it has some calculations, some conversions which we should know. It's a very simple one, not tough as mathematics, but still a bit practice is required. So children, this is the end of our chapter 2. I'll be giving the homework exercise, and I expect everyone to do this in your copy. Remember one things, whatever I'm teaching now is the final. You have to understand, you have to maintain your copy, you have to do that. Okay, so only the practical part will be taught when school gets reopens. The theoretical concept, whatever I am teaching now, that will be the final part. So you need to see this properly, understand it. Each and every calculation you need to follow it. Each example I have did, do in the same manner and try to understand this. This is clear, children? So your homework is this. Everyone should copy this one in your notebook. Oh, sorry, textbook. So see you. So children, your homework from chapter 2, some exercise are given, only question answers are full completed, which you need to simply copy. Rest like multiple choice, true, false, fill the blanks, you have to do by yourself. So children, see your first exercise. Fill in the blanks. The most common number system is a dash number system. You have to fill the dash. You have to write the appropriate word, appropriate answer in that dash. Number 2, the base of binary number system is dash. The base system, what is the base? Okay, like there are 2, 8, 10, 16, these are base, so you have to write that appropriate answer. Number 3, the base of octal number system is dash. Here also base. Number 4, hexadecimal number system consists of dash digit. How many digit hexadecimal number system consists? Number 5, in binary addition 1 plus 0 equals to how much? Dash. This all I have already taught in the video. If you see the video properly, you can easily fill the dash. Number B, write T for true statement and F for false statement. True, false. Question number 1, the decimal number system consists of 10 digit. You have to write T or F, that means true or false. Number 2, 1 multiplied by 0 is equal to 0. Whether it is correct or wrong, you have to mention that. Number 3, the hexadecimal number system has the base 16. Hexadecimal has base 16. Correct or wrong, true or false. Number 4, a binary number system can have only 2 digits, 0 and 1. Binary numbers, how many digits it have, whether 0 and 1 or maybe some others. You have to write T or F. Next exercise you have is multiple choice question. That means each question is having 3 options. 2 are wrong, 1 is correct. You have to take the correct answer. Number 1, in binary multiplication, 1 multiplied by 1 equals to 2, 8 or 1. The correct answer you have to tick. Number 2, To convert decimal number into binary number, divide the number by how much? If you want to convert the decimal number into binary number, you have to divide the number. I have shown in the example, but with which number? You have to divide by 2, 8 or 10. You have to take the correct answer. Which of this is not a hexadecimal number? Hexadecimal number means number from 0 to 9, then A to F. Now out of these three options, like A is ABGH, B is CD23 and C is 12, that is 1 to AB. Which one is correct? You have to tick that. Oh sorry, which of these is not hexadecimal? That means 2 are hexadecimal, 1 is not. That not one you have to tick. Number 4, which of this is not a octal number system? So again you have a 3 options. Okay, so octal means 0 to 7, only 8 are there. So which one fall in that category? 3 4 5, 2 4 1, 2 4 9. Okay, so which of this is not a octal number system? Which is not, that you have to pick. So this was your multiple choice question. So let us move to the next one. Answer the following. So you have 4 questions over here. Question number 1, what does bit stands for? A digit in binary number system is called a bit. Bit stands for binary digit, that means 0 1, these all are bits, and bit is also smallest unit for computer memory. Question 2, briefly explain the octal number system. Answer, octal number system has 8 digits from 0 to 7 with the base 8. So octal means 8, so 8 digit it has, that is 0 to 7. So this is question number 1 and question number 2. Here answers are also given, so simply you need to copy this one in your textbook. Question 3, what do you understand by hexadecimal number system? Hexa means again 16. Hexadecimal number system has 16 digit, that is 0 to 9, then A to F, where A represents 10, B 11, C 12, D 13, E 14, F is 15, and 0 to 15 is 16. Number 4, state the use of number system. Now this all are number system. Basically 4 different type we have: binary, octal, decimal, hexadecimal. Now what is the use of these number systems? Number system is a set of values used to represent different quantities. See, for us there are alphabets, isn't it? In Hindi also we have akshar like ka, kha, ga, ga, or. So when we type this one, then how machine understand these things? So this number alphabets or this maybe ka, kha, ga, ga, okay, these are converted to some numbers. They have some numbers using some code like gray code, ASCII code, Unicode. So many different codes are there. By that code, these alphabets are converted to some decimal or hexadecimal or binary octal form, and this octal, hexadecimal and decimal form numbers are converted to binary, then a machine understand. Machine process, again the machine convert that to decimal form and we people understand. So to communicate with computer we need a number system, whether we are typing alphabet or any other things, symbols and all. Each and every character has a decimal, octal or hexadecimal number, and these are used to convert in binary form. So children, this is the use of number system. So everyone will do this in your textbook. You will go through this one, you will read the answers also. Okay children, so today we'll do up to this much.